T-Rex was really big. We all know that. Here's a typical human doctor for comparison. But how big was the biggest T-Rex ever?
Officially, the largest T-Rex specimen we have in the fossil record is called Scotty. Discovered in Saskatchewan, Canada in 1991, it measures over 12 meters long and stands 4 meters tall. For comparison, the T-Rex in Jurassic Park is around the same length and stands about a meter taller. A terrifying sight, but could T-Rex actually get any bigger?
Well, in 2024, Jordan Mallon and Dave Hone published a paper that suggested that the largest T-Rex that ever lived would have been 70% bigger than our largest fossil that we have now. I have a question. How on earth can they know that?
To figure this out, they deployed some clever statistical analysis and modeling. Now, this method could be applied to many species in the fossil record, but they tested it in T-Rex, because, hey, T-Rex. Their assumption is T-Rex, like any other animal, would follow a bell curve in their distribution of sizes, like humans. You have an average, with half the animals above and half the animals below that average. As you get to extremes on that curve, you have fewer and fewer with extreme sizes. The bell curve represents a normal distribution, where the majority of a population clusters around the mean. The variation of size within a population is calculated into a standard deviation, where 68% of the population fall within one standard deviation each side of the average. 95% of the population fall within 2 standard deviations, and 99% of the population fall within 3 standard deviations.
If we look to humans as an example, the average human man is about 1.7 meters tall, or 5.5 feet. The standard deviation is about 7 centimeters. And what that means is that you would expect around a third of the people, 34 and a bit percent, to be 0 to 7 centimeters taller than the average. If you look up to the next standard deviation, between 7 and 14 centimeters taller than the average, you'll find there are far fewer people, around 13 and a bit percent. And if you go up to the next standard deviation, there's only a few percent of the people there.
So, the more standard deviations you go from the average, the more extreme the size. But the fewer individuals you'd expect to find at that size.
However, if you're looking at billions of people, you're expecting there's going to be at least one person who sits several standard deviations away from the mean. Take, for example, Robert Wadlow, the tallest human that we've ever documented, who came in at a staggering 2.72 meters or 8 foot 11 inches tall.
That's a staggering 14 standard deviations from the average height. But how many standard deviations could T-Rex push to the end of their bell curve?
The researchers played the same game. They said, look, we have 84 T-Rex skeletons. And if we put this on a curve, we can get a mean. And we can estimate a standard deviation. Those 84 skeletons are incomplete, so the researchers focused on the thickness of the femur or thigh bone as a reliable estimate of the animal's overall size. And by size, they are particularly interested in the animal's mass. But it's not as straightforward as that, because they also had to estimate the age of the animals in the fossil record, selecting those that represented fully grown adults. Now, is it fair to assume that T-Rex heights and masses followed a bell curve? Well, there's an animal that we can use as an analogy, and that's the American alligator. It's a reptile that has a carnivorous diet and has a similar multi-year growth pattern to T-Rex. So, do we have enough data on alligators to see what their growth curve looks like? Fortunately, the Mississippi Department of Wildlife, Fisheries, and Parks actually conducts an annual survey on the American alligator and has thousands and thousands of data points showing their size distribution. It indeed does follow a nice bell curve. This allows the researchers to estimate the standard deviation for T-Rex mass at 1,226 kilograms or just over 2,700 pounds. If the average mass of a T-Rex
is about 6,000 kilograms, then 68% of the population are between around 4,800 kilograms and 7,200 kilograms.
Now, how many T-Rexes ever lived through all time? They were around for 2.4 million years as a species, and paleontologists have estimated that there were probably around 2.5 billion animals.
There are two fascinating points here. One, T-Rex was around for a very long time, 8 times longer than modern humans. I wonder how much longer they could have kept going if that dang meteor didn't strike the Earth. Two, there are more than 3 times the number of humans alive right now than there have ever been T-Rexes alive. For a large land mammal, we're very prolific. But back to T-Rex size. The large population means there's a higher chance that an animal existed that falls into a higher standard deviation bracket. The 6th standard deviation is just 0.0000002% of the population.
However, when you look over 2.5 billion animals, you can expect that there will be one around 5 to 6 standard deviations above the mean, and that animal would be about 70% more massive than Scotty, the largest T-Rex that we know of by fossils today.
And that's a gargantuan 15 meters long and 15,000 kilos in weight.
Now, the authors do acknowledge we're not sure if T-Rex actually could have grown for physical reasons to 70% more mass. Maybe there's something about the way the heart can pump blood around the body. Maybe there's something about the way that the legs have to take the weight. Maybe it was impossible. But until we collect more fossil evidence, we'll never really know.
And because a fossil like this is so rare, it would be like trying to find a needle in 1,000 haystacks.
Until that time, keep watching this space, and remember that between the question and the answer are all of the really tasty bits. Hey buddy, my ancestors were around at your time. Why didn't you survive the asteroid? I guess I was just too big.